These are examples of problems you might see when we're talking about extrema and the critical points and things that we just talked about in the previous lectures. And so we want to take a look at, well, okay, what do all those things mean? Now, I did pull this from another book, and so I will say that I personally, the way it's set up, I do not necessarily agree with how the book answered the question, but I'm sure there's a good reason. Let me draw on this. This is how the book presented it, and the question was, label each point as an absolute max or min, a relative max or min, or neither. And so we have this issue here of, okay, well, what are the maximum minimums? And so if we look back and we really start kind of digging into these definitions, the definition of an extreme is let F be in an interval or defined on an interval I containing C. So we're looking at absolutes. Now here's the problem. Absolute minimums cannot occur at open circles because that point is not in fact contained. Okay, so D is not an absolute max or minimum. However, B is. B is an absolute max. Okay, it doesn't matter the interval right now, where you could assume we're going from A to G. It really doesn't matter. And so, since we're considering the whole of the function, pardon me, my voice is really thrashed right now. I'll probably remake this video at one point. But anyway, point B is the maximum on the function as defined from A to G. And so there are no other points that are greater than that point. And so that's fine. Now the problem here comes in if we look at A. Now this is on a closed interval, and this is the problem here, because if you look at the definition of relative extrema, it says if there's an open interval containing. Here's where you have to be careful, because right now they didn't really give us what our interval was, so we're assuming that it's A to G. Okay, but essentially what you can do is you can look at this. Anytime there's a little hump, that's a relative one. C in this case is not. It's not a relative extrema because in the open interval, if you have on either side of C, C is not going to be a low point or a high point. So as we look at it, A will not be that. B will. C won't. D would have been had it been defined. However, if we throw an open interval here, this is where I think the particular book that I looked at was getting its answer from. If we look at the open interval that contains E, then you find out that E is in fact a relative max, and that its partner F is a relative min. Okay, after that, there's really nothing else to be said. Now, that's pretty iffy, and so really, from my students anyway, I would have accepted that B is the only thing, because if I don't say check from this interval to this interval and make it open, then as you look from A to G, it's a closed interval. There are no relative maximum minima because it's a closed interval. So I would have accepted both. Okay, so moving on with these, they're looking to find each indicated extremum if it exists. So find the value of the derivative if it exists, and find the relative extremum if it exists. And so as we look at it here, we notice that in the first example, there is a relative extrema and it's a relative minimum. Okay, and the derivative, the value of that derivative, or I should say f prime of 3, is 0, and it is a relative minimum. Okay. On the second one here, we notice it's a cusp. Now here's the problem here. We want to find the value of the derivative if it exists. A cusp does not have a derivative at that point. Okay, so f prime of -2 does not exist. So we got to be careful on that one. However, it is still a relative min or max. And so it's a relative minimum because it's smaller than anything around it. Okay, so that's how these style of problems work. Now for something a little bit more demanding, perhaps, it's still we're still looking at this idea of relative mins and max, that sort of thing. However, this is a little bit more defined, and the instructions say approximate the critical numbers of the function shown in the graph and determine whether the function has a relative min or max or absolute min or max, or none of these at each critical number. Okay, critical numbers. They were defined wherever the slope of the derivative, or wherever the derivative is 0, and also wherever the derivative does not exist. Right, so let's identify some spots here. Here is a spot right here, and right here. At these 2 points, the derivative is 0. This is a cusp right here. So at that point, the derivative does not exist. Okay, so those are our critical points. And now the question is, are these relative maxes or mins, absolute maxes or mins, or neither? All right, well, assuming, and depending on how well I've drawn this, assuming that that 3 is the y value of each of these coordinates. So we have 1, 3, and we have 3, 3. By inspection of the graph, you can see that these are in fact not only relative maxes, but also absolute. Okay, we're talking about open intervals, so they can be relative, but they're absolute because there is no other, on this function as far as we've defined it, there is no other higher point. Okay, that's simply the definition of extrema. On the bottom side of this, though, we have a point where it does not exist. And so the question is, it is a relative minimum simply because of the definition. Okay, so we have an open interval, and so that is a relative min. And it's also an absolute min. And the reason it's an absolute minimum is because of the open interval that we're looking at x equals 0 and x equals 4. There are no other points lower than that on the y coordinate. And so that's really how you start dealing with these on a more conceptual basis, just using the definitions and using what you know about derivatives.